just going to try to make some of these things on my screen go away. How do I do this? No. Well, we'll just go ahead. Thank you so much. Happy to be working with you all. And let's just dive right in. So anybody who's seen any of my presentations the last few years probably knows this slide. And just to say that whereas most states and cities are always arguing about whether they should go ahead and do this energy efficiency stuff or not, we have legislative mandates at the state and local level. Says do it. You know, people with the expensive suits come up with these ambitious plans, and then they sort of throw them over one shoulder at people like us and say, okay, make it happen, and try not to piss everybody off while you're doing it. Coming up with the Seattle amendments to this, sort of 4 basic principles that we talked about, but today we're on to HVAC, which is numbers 2 and 3, and basically it's saying let's move to heat pumps and let's figure out every way we can to not waste any of our clean electricity while we're going on it. In fact, at the very beginning of the code, where it says what the code is about, it's been changed to say it includes not just energy reduction but carbon as well. And when we're going to dive into this, there are certain categories of energy use in commercial buildings that are huge. I once did a great thing on escalator efficiency, but you know, it's not going to move the needle much. So what we really need to do is to continue working on those big slices and pulling those down a lot. By the way, anybody who's got questions, if you could, there's a chat function here, right? You could like type them to the organizer. I'm going to deputize Carmen to interrupt me now and then when there's something that I just haven't explained that I ought to.
Absolutely. Monitor the comments, please.
Yeah.
Into the chat.
And especially the best ones are the ones that take a few seconds to ask and a few seconds to answer, because probably if you've got that question, a lot of other people do as well. So I went through, last year I went through the code, the HVAC section of the code, just to try to figure out, you know, what's the overall organizational principle, and it turns out there isn't any. This is, I think people have just been throwing things into this section for decades, and so this time, instead of trying to go through the whole thing and cover every little thing, which nobody could possibly remember anyway, I started working with our inspectors to try to figure out, you know, how they could best use their time, and we started coming up with a top 10 list. So things that are highlighted in yellow here are part of that, and then along with the top 10 list is there's things that go with individual occupancies that are shown in the blue highlight there. So this.
Okay. Yeah.
We have to remute again. The question that I have for you all, that maybe at the end we'll have some time to talk about, is, did I get the right ones? Did I get the ones that move the needle towards energy efficiency the most significantly, or did I miss something, or did I put something in these lists that really doesn't belong there? That first one you saw on that list, commissioning, here we go. What I'm telling the staff is, here is on the plans, something says commissioning is going to happen, and out on the site, somebody's going to ask the project manager of the contractor, let's see that mechanical portion of your commissioning report. Let's make sure that it actually happened. We have not been enforcing that well in the past, but things, they are a-changing. And this allows us to look much deeper through the commissioning agent than we could possibly have time to do on our own. So you'll just, you know, you got to say who's managing the commissioning. If you're commissioning your own stuff, you got to have that conflict of interest statement, and then there's various checklists and reports that have that have to go along with that. So number 2 would be metering. Another thing that has not been consistently enforced in the past and will be in the future going forwards, and we would just see evidence in your HVAC plans that there's outputs to a metering system, and then out in the field, the inspector would say, okay, turn this thing on. Let's see it actually work. Really important. People are spending a fortune to comply with all our rules, and then if there's no way to tell whether that's working, it's tough. So that just really means, and we got some thresholds that you have to be above before we get into that, but it's going to require that there's a display that the building manager can use, looking at things with various time frames and looking at the source energy and the various sub-metering loads there. Note that I put in bold that it also applies to replacement HVAC. That when you're putting in a new or largely new HVAC system, you'd have to at least meter that and the incoming energy. The next one would be what's big this year is in Seattle. You're not going to use fossil fuel or electric resistance for heating most of the time. So your plans would show you got a heat pump system, or they would clearly show what effect you're going to make. Remember that slide way up the top said we gotta get somehow to that very low energy use and low carbon emissions status in a hurry. And the easiest and best way is to start with new construction. So that one is going to just basically say you're going to use heat pumps unless you meet one of these many exceptions. And the big one I've got there shown in red is in an apartment building, you can have 750 watts per room. That we've checked out and is generally easily sufficient to run your building. And then there's lots of other exceptions. The ones on the left are mostly about where you can have the supplementary electric resistance heat kick in and how much there can be. And then there's lots of other specific exceptions that are just small loads or temporary loads. Along with that one, just note that the state has mandated that refrigerants are phasing out, the ones with the high global warming potential. And note that this is for the date that the equipment is manufactured, not for the date you get your permit. So if you've seen that little red box below, you apply, this goes into effect in mid-23, so you apply somewhere later in 23, you get a permit in 24, you dig a hole and start putting up the structure. By the time you're up and ready to source those pieces of equipment, we're already in 2025, if not 2026. So plan accordingly. A little thing is just that I kind of muffed the refrigerant piping, and so as an interpretation, we're saying that the hot gas line on refrigerant piping would be inch thick outside of the building and ½ inch inside, and then for the liquid lines, it'd be a ½ inch for mini splits or where the manufacturer wants you to have that, and otherwise none for those liquid lines unless they ask for them. And I won't get into this much, but there's a number of different types of systems you can use that would, and thanks to FSI for this list. And the ones that are cheaper, of course, are less flexible and perhaps less useful. And as you get into more deluxe systems, it is definitely requiring a little additional money, and you'll have to negotiate where you'll land on this with your clients. my question in red down there is, I still run into engineers all the time locally who say, you know, oh, heat pumps they just crap out at 42 degrees. They don't work anymore. And which was, I guess, true 20 years ago, but just getting into this current century, there's plenty of capability in that for even the single speed ones to get down to what is already Seattle design temperatures, and you can get down into Eastern Washington design temperatures with better compressors. So it is possible and now mandatory that you find something that works, and it really shouldn't be a problem these days. The next one on that top 10 list, do the TSPR, the total system performance ratio, and this is now being picked up and proposed at national levels as well. That we're using it as a backup here in Washington State to ensure that the system that you designed is as good as what we've determined to be a pretty good system. But other places are saying, well, no, you just use the TSPR instead of the whole 403 section of your code. There's a lot of exceptions you can see in the red box there that I won't get into, and those often deal with systems that we just didn't have the budget to properly evaluate and put into the formula. But that is meant to be a ratio of those total loads on your coils compared with the carbon emissions from your buildings, and a higher number is better. Seattle has added multifamily and medical office to that list of 4 that the rest of the state has, and PNNL has a really spiffy tool that allows you to do, it's kind of like a mini energy modeling, but you could do in a few hours what would a building that for full-fledged energy modeling would take you a few days or a week to do. Number 5 on the list is DOAS, and the essence being that your heating and cooling is decoupled from your ventilation flow, and I'm showing that picture of the auditorium because we have now added assembly occupancies to that list of space types that need to have DOAS. But on the plans, you're just going to show that system, and then it's going to have to match out on the site. So like I said, we added assembly, and we took away some bonus prizes that we had originally given the first time around with DOAS. So you don't get some of the extra code benefits that you got last time around. We in Seattle made an exemption for accessory occupancies to just clarify that if you've got a little office in a warehouse, that doesn't mean you have to do the DOAS for that one little space. This is now, instead of just being text, this is a table, which makes it much more useful. But the first 4 rows of this table are the different assembly occupancies, and you can see that with well, I should point out one, and that's the second line down for where it says A2. That's typically dining, and that is exempted because it's part of restaurant. But as far as exhibition halls and gyms and libraries and lecture halls and all that, those are included. The B row down below is an interesting one because there's a long list of exclusions, and then everything else in B is included in requiring DOAS. So advice is to use fan walls when I first saw this picture, I thought it was somebody's collection of gold records. But you got a fan wall there. Since say a concert hall or a lecture room with somebody just practicing up on the stage, so there are 3 people in the whole thing, is going to be just this tiny amount of ventilation required, and then an hour later it'll be a huge amount. So using fan wall system instead of one big fan would be a lot more sensible way to handle that varying load. And economizers, not exactly a up-to-date or extremely foxy concept, but it's still important that, and we've made it clear that you do still have to have economizers with a DOAS system. You can't just get out of that unless your chiller is like somewhere really inaccessible to outdoor air. And note that in Washington State generally, if you have both DOAS and you have a demand control ventilation, then you don't need an energy recovery. But in Seattle, if it's more than 650 square feet with DOAS and DCV, then you do need energy recovery. There's just plenty of air there with plenty of energy that we can pick up. And we have just changed that occupancy limit in Seattle as well. Instead of 25, it's gone to 15, which adds retail, which I don't know if we ever get back to having regular retail. Note that you can have a holiday season crush in a basement that is has several hundred people on a floor, and then on a Tuesday afternoon the following January it's 3 people on the floor. So once again, great use of demand control ventilation. And here's where we've taken the heat recovery effectiveness from 50 up to 60%. Seemed like it wasn't a big deal, and then we exempted certain hospital and lab spaces. And finally, on this topic, well, that's just the text that showing that in Seattle, you got to be smaller than 650 square feet for your conference room or whatever to get out of this rule. Number 6, economizers. You got to have the economizers or meet one of those many exceptions. Still a great thing for our particular climate in Western Washington. And 7, heat recovery. We say energy recovery, but there's not a lot of summertime energy recovery. It's really mostly heat recovery. The plans would show that at its new efficiency level, and on site, the inspector would just have to see that it actually is moving things as it's supposed to. Especially now that people are concerned about having lots of outside air circulation. This way we can have that without taking a huge energy penalty on it. I lumped, for number 8, I lumped together controls. Thermostats, door switches, whatever, but those are still significant, and the plan's just got to make sure that things are controlled as they're supposed to be. And on the site, considering that we have commissioning authority coming through and looking at them more carefully, the inspector would just do a little spot check. The idea being that we don't just run things full tilt, as was done in the olden days all the time, but rather we let those systems slow down when they don't need as much, or turn off when nobody's there at all. 9 would be that we have further DDC requirements in the code now, and we just got and extending to more building types. And 10 of our top 10 is that we've got these C406 credits. You need currently 6 of them in Washington State and 8 in Seattle. And notice that I put a couple of asterisks by a couple of those that don't work in Seattle anymore. But the idea was that rather than just having more hard and fast rules, that we would come up with a list of stuff you could choose from, so you could pick the things that are the most beneficial to your particular clients and still get the extra efficiency. So you'd see this system there. I've circled, okay, you're doing a school, so you can start off right away with 2 credits for having your HVAC equipment perform a little better. And in Seattle, that would mean you just have 6 more credits to go. This is something that you really need to do as early as possible in the design process, because which of these credits you choose is going to heavily influence a lot of other things that happen in your design. So please don't let your architect put this off for some future meeting. Get it nailed down at the very beginning of the project, which credits you're going to go for. It's really painful to try to add those in later. Note that we've got some language in there that clarifies that if you have some high-performing central system for the building, and you do a tenant space in that building and plug into that high-performing central system, that you can get credit for that space. Before I go on, Carmen, do we have any questions that need to be picked up right now?
Yeah, we have several. Are you ready?
I'm always ready.
Okay, we're going to go back towards the beginning of the conversation here. Is commissioning required for central domestic hot water systems?
Yes, and for each one of these, there is a threshold. But any central system for a multifamily building or a hotel is probably over that level already. A central system that just served toilet rooms and break rooms in a medium-sized office building, maybe that wouldn't be big enough to require. So it just depends on whether you hit the threshold.
Great. Briefly, electric resistant heat is all but banned. And I would also ask folks, if you aren't speaking, if you could mute yourself. So again, the question is, electric resistance heat, is it all but banned?
It is not allowed as the top line, and then as you saw, it had many exceptions, and so like that 750 watts per room for an apartment, or 1,000 watts for a corner room, and there are many other small systems, supplementary heat for heat pumps that can qualify. But in general, for larger systems, yeah, you don't do electric resistance anymore.
Thank you. Next question: Are DOAS is DOAS required for commercial coach portable classrooms?
I don't regulate portables. I think those are entirely labor and industries in at the state.
Good point. Next question. The last time somebody attempted the TSPR, the console for multifamily housing is not yet online. Any ETA on when that might happen? Multifamily housing.
I think that exists, and for some reason they set it up. It was a little tricky to find, so please email me and I will send you the link. Kathy,
email Duane for that information. Next question: 60% total effectiveness, or is it 60% sensible effectiveness on the HRV? I'm assuming, or sorry, the ERV.
The ERV needs to be 60% enthalpy. And then there was an exception in there somewhere for certain types that it could be, I think for hospitals and some other things, that allowed it to be 60% just sensible.
Bill, hopefully that clarifies your question. If not, email Duane or the Puget Sound chapter. Next question. Are there trade-offs possible in TSPR between envelope and HVAC through the modeling protocol?
No, this is the interesting thing about TSPR is that it is independent of how great or terrible your building envelope is or your loads in the building. It is only saying that for particular amount of heating or cooling energy that your coils are transferring, that how efficient are you at doing that? And sometimes you have to, I've heard people comment that they had to go back and spec a more efficient fan or slightly enlarge their duct sizes or pick up a more effective piece of equipment, but something to get them down under that line. So the system does seem to be working as required.
Great. Will electric heat still be allowed to be used, for example, in large, older office buildings that currently use electric VAV boxes when adding new boxes to or modifying these systems? Yeah,
good question. And we'll get into alterations at the end of the meeting, but the requirements for alterations apply to central systems and not to distributed systems, because it just sounded like too weirdly difficult to deal with individual fan coils or something around a building.
Great. Next question. Are dwelling units in a low rise under three stories or less required to meet commercial or residential code, or both?
If it's 3 stories or less, then they only meet the residential code.
So that is the rest of the questions we have to date, so we can move on to the portion of your presentation. Keep the questions coming in. We'll keep answering them as time permits.
All right, let's go. So we got some special occupancies I mentioned. Just note that in a commercial kitchen, there's we require statewide some controls on the fan speed over the grill to make sure you're not running at full speed when nobody's doing anything. And then in Seattle that those kitchen appliances have to be Energy Star. Data centers, just note that we have taken on, well, I should have said Seattle on this one, that Seattle has taken on 90.4 2019 because they just really improved a lot of things in that. Whereas with the state code is still requiring compliance with the 2016 ASHRAE 90.4 and has just modified a few things to make it a little more stringent. The best thing about the 2019 is that they separated large and small data centers, and that helped iron some things out. And if you're wondering what's a data center, 20 watts a square foot of information technology equipment is kind of the differentiation between a computer room and data center. Refrigerated walk-ins and freezers and frozen warehouses and all that have their own section, in C410. All that information is combined together there, and we just have to make sure that you've done, if you're doing one of these, that you've complied with that whole set of regulations. It shouldn't be too hard because these things typically come as big packages, and the local vendors are certainly familiar with these rules. Multifamily, you've got to and this is energy code and mechanical code, you've got to have balanced ventilation with heat recovery. So you can't use trickle vents and exhaust only system anymore. And those never did work very well, and especially if you were on the upper floors of a building that's more than a few stories tall, you often had it working in reverse with the air coming up the elevator shafts and through your apartment and out through the trickle vents. And then this was just her trickle vents were horrendous when we had the wildfire problem. So gotta supply them with air, got to exhaust, and you got to have some way to recover that heat. And it's at 60% effectiveness that we've got to have. Loading docks, they're another tricky one. Ventilation ramps up when there's contaminants in the air, and so your plans have got to show that those sensors and controls are working, and then somebody out on the site has got to be able to show that this is actually turning up the ventilation when there's stuff in the air there. We've been seeing a lot of these outdoor cafe things lately with radiant heaters, and just to say that in Seattle you've got to have a 20-minute max on that shutoff, and we also applied it to unheated spaces. So if you have an unheated storage area, or say you've got an unheated equipment storage shed, and you can have one of these over a bay where somebody's working on an engine or something, if it's got that shutoff system. Labs are another energy hog, and so you got to have heat recovery for a lot of situations there, or meet some of the exceptions that they have, so you just have to have controls showing how you're going to do that heat recovery. Hotel guests, we have setback controls for the HVAC system, and there's some much spiffier systems available now that all the big hotel chains are taking on, but this would mean that you wouldn't have that space really refrigerated in the summer if the guests are gone all day. And I think this might be my last special occupancy. Grocery stores just need to have heat recovery from any kind of refrigeration that they have. When it goes over a particular threshold, and I just talked with an engineer a couple of days ago who said, yeah, a big grocery store for sure would be over that threshold. A medium-sized one like a Trader Joe's or something probably does, and your corner grocery or a big restaurant with walk-in coolers probably does not go over that threshold to need that extra. And that heat recovery can come there. There's other heat recovery that's required for large hospital systems, for places heated with steam. So check those out, and that's one of those things that can make you look better when you start having to deal with building performance standards. Before I go on to other stuff, you want to catch me up, Carmen, on questions?
Yes, we have 2 more questions. Can you please discuss the apparent conflict between Energy Code Maximum and Mechanical Code Minimum for commercial kitchen hood flow? Which takes precedence?
Remember that the commercial kitchen hood flow requirements are to back off with when there's low usage, and we process these all the time and have not found any conflict between the ventilation requirements and the energy conservation requirements. So those do work together.
Douglas Smith, I hope that answers your question. Next one is, when can you use a high efficiency OHVAV system? I'm presuming that means overhead VAV system. Unless I'm mistaken, Seth Pike, if you want to clarify, when can you use a high efficiency OHVAV system?
You can use and that's the alternative to using DOAS is you could do the high efficiency VAV. That said, we have had extremely few people take us up on that high efficiency VAV system. It was put in there because when we were saying everybody has to do DOAS, some people said, hey, wait, the way we do VAV is great. You should see it. It's terrific. So we made this alternative that said, okay, you can do a really good VAV system, but it turns out that's almost always more expensive and not worth the trouble. So yeah, you can. I don't think there's any constraints on when you can do the high efficiency VAV.
Thank you. Next question.
All right.
Have you seen projects utilize a high efficiency DOAS C406 credit? We have looked into it and found it to be difficult to achieve.
You know, I'd have to check with our plan reviewers. I don't know how often they've encountered the high efficiency DOAS, and it might be one of those things that works really well for a certain building type and not well for other building types. That's all I can guess.
Thank you. All right, with that, we can continue. We only have about, let's say, another 10 minutes left before we can wrap up with Q&A.
All right, so we'll go real fast. Just remember that we've gone to Appendix G ASHRAE modeling. That would say your building performance factor indicates that for an office building, you can only produce 54% as much carbon emissions as you would have designing to the 2004 ASHRAE. And then Seattle, to balance that out with all the other requirements that we have in the prescriptive code, goes 10% better than that. In alterations, in general, if something was built legally back in 46 or whatever, it can just stay there. But and you can repair it, you can service it. But if the new stuff has to meet the new code typically, and if it's a substantial alteration or a change of occupancy, change of space conditioning thing, then it's more like complying with the new code with some little breaks that we give you. And so you're going to go and replace your heating equipment. In general, your central heating has got to be a heat pump. And with this exception at the bottom that says, okay, if you have a single piece of equipment that is failing, you can replace that like for like right there so that people don't get stuck in January with no heat. But it doesn't work if it's part of a bigger project or if it's multiple pieces. So it's a question I have for all of you is, how are we going to get to our carbon neutral goal if we don't do this? We know it's expensive and disruptive, but it would be the least expensive and disruptive to do that changeover at the time you were otherwise going to replace some major equipment. Other jurisdictions have said, okay, you got to upgrade at time of sale. I think New York City is saying at a certain point in the future, you got to upgrade. There's better financing available now, but we're aware that all those things in the red box are big deal. That it takes what should have been a $40,000 project and makes it a $400,000 project in some cases. I'm really interested if anybody comes up with some better way that we can make this shift. There's one little thing you should be aware of, that if you're upgrading from some fossil fuel heating system to both heated and cooled, typically you need to, that's a change of space conditioning, you need to comply with full Seattle code. But we're saying if you're upgrading to a heat pump and you can prove that the overall annual energy you're using with both heating and cooling with that heat pump is less than you were using with your old furnace, you're golden. Just note that the building performance standards are creeping up on us here, and Seattle is going to start its own building performance standards that have a smaller threshold, 20,000 instead of 50,000 square feet, and will be based on carbon emissions. So converting an old building from fossil fuel to heat pump will get you both of those, and probably is going to be way more economical than trying to redo your envelope. So we arrive at the end that with Mark Frankel's good old quote, that which exists must be possible. There's examples like these around town of very high performing buildings that were built with really reasonable budgets. And so it's already possible. We got to change our habits and move into it. And with that, Carmen, you could ask more questions, or we could just turn it over to you for wrap up.
Yeah, we have a few more questions. Thank you. So, will this presentation PowerPoint will be available after this meeting? Absolutely. We have been recording and we will post it immediately after and send out an email to our members. So next question, getting to carbon neutral will require thermal envelope upgrades, not just HVAC. I guess it's more of a comment. You just made that point as to these available opportunities. Duane, do you want to speak to that regarding the envelope versus equipment efficiencies?
Yeah, changing out a building envelope is usually not a real good bang for the buck. And so HVAC and water heating and lighting control systems are certainly getting us more carbon reduction per dollar invested. And it may be that in some of the out years, we have to start changing out our windows. Yeah.
Thank you. Next question. When we change from gas to heat pump as a heating source in a retrofit, does the fact that we are adding cooling trigger a building permit application?
If it's a purely HVAC job, then no.
Easy. All right, if anyone in the audience has any further questions, feel free to type them into the chat. Otherwise, we welcome your questions. After this conversation, we will put together a summary of any existing questions, and we can go forward with that. Otherwise, we're getting ready to wrap up here. Anybody else have any questions, or anybody on the board would like to wrap up?
Looks like a few more came in, Carmen.
Thank you. I'm just looking at those now. Yep. So, okay. If a gas boiler is replaced by a gas-fired heat pump at significantly higher operating efficiency, is it considered a like for like?
Yeah. Like for like would just say that the capacity is no larger and the efficiency is no worse than the existing.
That's easy. Thank you. Now that you have given us the 2018 code highlights, are we still on track in Washington to have a new 2021 codes as of December 1st, 2022? I saw that SBCC website some time ago.
We're having the final, any comments you have on the proposed Washington State Code are due this Friday, this week, and then the Code Council is going to have a couple of meetings and then vote on this in May. So then we will see.
Last chance to get your comments in by this Friday. Okay, last question, unless somebody else posts something in the next minute or two. How are we going to carbon neutral when we are using carbon-based power generation for electricity that has distribution losses?
Well, Washington State is committed to wringing out the last parts of its of the carbon on its grid, and removing those that fossil fuel from the system. So we're at the same time we're adding renewable energy to the grid. We're taking away coal plants. Eventually, we'll be taking away gas plants, and working to reduce the overall amount of electricity we use to make more room for that. Remember, we have to also have room for all these electric vehicles that are going to be coming up. So keep pushing the efficiency to make room in our current grid capacity to handle the switch over from fossil fuels in buildings and from cars.
Thank you. Jack Ziegler had sent a link in the chat regarding the DOAS and high efficiency from Better Bricks. Jack, I think we'll separately make mention of your question on a separate conversation thread. Brian Edwards says, regarding retrofit applications, what happens in a situation where there isn't either sufficient electrical infrastructure and or real estate to replace a boiler with a heat pump, meaning there's not enough space? What are your thoughts regarding that?
No, these are really difficult questions. Obviously, if you have a large building and you need to bump up to the next larger size electric service, it could mean you have to have a vault. There's a lot of, and so we recognize that's a big expense. I'm hoping that the advent of PACE financing is going to help iron that out to some extent. And then with space, it might be that you have to create, you either have to take over space in your building that's been used for other purposes to expand mechanical space, not popular with your management, or get a heat pump type that can work in all temperature conditions that we experience here, and have that on your roof or elsewhere on your site.
Thank you. Thoughts on combined heat and power?
I think it's a terrible idea for us because once you build a CHP plant, you've locked yourself into essentially creating heat with gas for 40 years or whatever the lifespan of that thing is. So it's absolutely the wrong direction to go for us.
Thank you. Any thoughts on thermal storage into the code to help develop, to help offset peaks and give the grid some breathing room?
I think this is great. If you have a heat pump that's doing your domestic water and can go just chugging along and stop during peak hours, and then get you enough, then you've got water. If you want, I think in California, because peak energy is so expensive, ice storage systems are really economical there. But having some way to store some additional heat, which would mean some kind of mass, would be terrific. Also, ground source heating and cooling would be excellent for that.
And unless anybody types in a question in the next moment or two here, we are at the end of our questions. Duane, thank you so much. This has been really enlightening. It's been really wonderful to hear your thoughts and comments, especially as we're moving forward into the future and also into the next code cycle. So things that are adopted and accepted and we have to comply with, as well as things that we can have opportunity to tweak in the next couple of days at least, to bring forward comments. Any final thoughts, Duane?
Yeah, I was serious at the beginning when I said I'm looking for your ideas about, did I get that top 10 list right? Did I put something in there that really isn't that significant? Is there something else that I should have had in there that is a better thing for everybody in the community to be focused on? Please let me know your ideas.
And with that, we're going to end the call. Give 5 minutes back to the audience. Thank you so much, Duane. We'll be posting this video very shortly, and we'll see you again in our April meeting. Thanks so much.
Bye, everybody.
Thanks, everyone.